Alright, in this third video we're going to be looking at the geoprocessing tools again, but at this time we are going to be looking at the overlay tools. And what I really want you to think about overlay tools in a way is they are like a Venn diagram. And so what we're interested in here is intersecting different aspects of polygons, and in that we're going to get different types of results. So I want to go through each one of these. What I've done is I've set up our data again. Remember, we're looking to somehow understand the geography of stocked trout streams in Mercer and Butler County. So the first thing that we can imagine in terms of overlay tools is, in a sense, getting rid of some geometry. And that's where we use the erase overlay tool. Erase, what it essentially does is it cuts away content within an area. And it's important to distinguish. If you think about the clip tool, what we've said is we have cookie dough, and we take a cookie cutter, cut the dough, and what we get is the cookie that we've always been interested in. In the case of the erase, what we're really doing is we have a series of cookie cutters, we have our dough, and we're going to throw out everything that's inside the cookie cutters. So let me show you this. What we'll have is our example. Again, we're looking here. Let me get this out of our way. And we have our Mercer and Butler County, okay, and you can see those here. And then what I'm going to add to that, in a sense what I want to get rid of, we're not really interested in land that is in state game lands. In other words, state game land are areas that are already to some degree protected, and so we're not really looking at those. And you can see their area here. The other area that we're interested in is our 15-minute drive time. So I'm going to add that now. And what you'll notice is that in some cases right here, and we have a little bit of an area right here, these are areas that we want to cut away from the drive time. In other words, we're not interested in leaving that as part of our drive time. And so what we're going to do is we're going to erase those features. When you look at the tool option, I'm going to open it up real quick here, the input feature is the area that you want to cut away from. So in this case, that would be our 15-minute drive time. Our erase feature, so again, let me add that in here, our 15-minute drive time. Our erase features in this case, we want to get rid of the state game lands. So I would add that in. Now, the result of this then is going to be the geometry of the 15-minute drive time minus the state game lands. Now, the important thing to note, because this is a feature class, remember, file geodatabases are topologically consistent, automatically the area and perimeter calculations are going to be updated. Now what I've done on this, and I've already run this, so you'll see the results in just a minute, but what I want to point out is what I did with the clip coverage, the drive time coverage, is I added a field here. And I also added another field so you can see how certain things are maintained. But you'll notice that the original area here, and this is in hectares, 37,557. Now you'll notice that that's consistent with, when you see shape area, that is the internally calculated field. So any modifications to geometry will modify that. But it won't modify this field. And that's why I put it in, so we can see what the original looks like. Now, once I've run this, and so again, what we're looking at here, what we're going to see, I'm going to zoom in a little bit so you can see the area that I'm going to focus on. You'll notice right here, here, and here, there are areas that are going to be cut away in the resulting output. So let's take a look at our resulting output. I'm going to activate that data frame. And again, we're going to get rid of everything except for our erase options. We're going to be looking at all of these in just a moment. And what I have here is the original 15-minute drive time area, and then the results from the erase. And what you'll notice right here is that part of our area has been eliminated. In fact, I'm going to zoom in here, and you'll notice a number of areas that have been cut away. The green is what remains, the blue is what was cut away. The other point that I want to make is, now that I go into my attribute table, you're going to notice that the analysis area, okay, that's in a sense the shape area, is the one that is continuously updated anytime we change geometry. But you'll notice my original area was not updated, and you'll notice that this area has gone down. In fact, we've lost a little bit of area. So again, feature classes topologically consistent. If I cut them, if I erase them, shape area and shape length, that is the perimeter, are going to be modified. Any fixed original areas are going to be maintained. So now, in fact, I could run a calculation that would be the original area minus the shape area would give us the difference, what we've lost. Okay, so that's the erase option. All right, now we're going to go back and we're going to look at, again, I'm going to activate our upper screen. We're going to go through a series of these. When we look at this area, the next tool that I want to think about, so again, erase means get rid of some of the information internal to a polygon. The identity tool is used when we have a dominant area, in this case what we're really going to call the input area. And again, we're going to conceive of this one as what we're interested in here is the drive time area and Mercer and Butler County. And so what I want to do is I want to bring those two together. And essentially what identity does is say maintain our focal area and then intersect with it. And again, I know I'm using intersect here, but when we're talking about identity, we're pushing these two together. And our result is going to be something a little bit different, and you're going to see why it's important. So now what I have here, again, in this case, what I'm going to do is we're going to put our input is going to be our drive time. And then the identity, and essentially what the identity will do is give information to that, I'm going to use as our Butler Mercer. So essentially what I've done here, and I'm going to show you on the map here, is I'm going to keep the drive time, and what I'm going to kind of push through it is going to be Butler and Mercer County. Now all that's going to be retained is going to be these two areas because that's the input. Now I could flip that around and I could say, well, I want to maintain all of Mercer and Butler County, but I want to push, in a sense, into it the drive time. So either one of these would work and we'd get different results. So let's take a look at our results on this one and we'll see what we get. Now again, I'm going to zoom back out and I'm going to turn off our erase option. And again, we start here. This is our original polygon. And once I produce an identity of it, in this case, again, I wanted to keep everything. So now I've got all of Mercer and Butler County in this case. And what it's essentially done is it's split the drive time along each area. So now we've kept both areas, but we've now given it new information. And again, what I want to do is look a little bit at what we're getting out here. If I look at the first polygon, what I have is, in terms of the information, it maintains its original FIPS code. You'll notice this is 085. We're way up at the top. And we can see that in terms of the drive time information, it's not maintained. There's nothing in it because there was no drive time for that area. In this case, though, I have both the drive time information, this is 0 to 15, and I now have the county FIPS. In this case, I also have the drive time, but in this case now it has the Butler information. So again, this is, in a sense, that identity. It gives to these two pieces the identity of this information. So identity, again, if you look at the tool, what I want you to think about is whenever you use this tool, the input layer is going to be the area that's maintained. The identity is what's going to be intersected, and in a sense put in to the other. Okay, so again, the identity tool. The next one we're going to look at, again, I'm going to activate this again. We're going to go back. We're going to turn that. So remember, we have our Mercer Butler County. We'll turn that on and off so we see kind of what we have, and our drive time. Okay, next tool that we're going to be looking at is the intersection. Now, intersect is truly that. The output from this is the areas that both or multiple feature classes share, and all that you will get out are the areas in common. So in this case, you could put in as many features as you want. I've never actually tried to see how many it will allow, but typically 2 or 3 or 4 feature classes are put in, and what we're looking for are the areas that are co-occurrent in all of them. Now the important idea here though is that when you do this, it will take all of the attribute information from each of the inputs and put it into the new table. As a result, sometimes your attribute tables can get quite large depending on the fields that are present. And again, you can deal with that by limiting the input fields and the output fields. But again, in this case, all that we're going to do as an example is we would put in our counties, our Butler and Mercer County, and we would put in this case, our drive time, and then our output. Now again, join attributes, you'll notice that you have some options here, and you can put in all of the information, which is what I generally encourage you to do, or only, for example, FID fields. Again, generally speaking, I encourage you to put all of them in, but that may be something that you want to decide. Now, I'm not going to run the tool again. I've already run it. We're going to look down here, and what we'll see again, now remember, this is our identity tool. Okay, that gave us the output of our larger area and our inner area and split. When we look at our intersection, what you'll notice now is that, again, it's split along the line of Butler and Mercer County, but what we get out is only those areas that are in both feature classes. And again, if I had 3 feature classes or 4 feature classes, I would get an even smaller, typically, intersection. Okay, so again, intersection. Now contrast that with the idea of a union. What a union will do is it will push, again, our data together, and it will give us all of the features from all of the inputs, but for each of them, for any areas of overlap, all of the information of overlap will be included. So again, in this case, we can put in, for example here, our clip and our county. And again, you'll notice here that we could put in all of these. And what's important to understand in here is the rank. The ranks will be part of our results. So again, put them all in. And what I want to do now is look at the output from this. And our union, remember, here's our intersection, only the parts that are co-occurrent. Our union, in contrast, are all of the parts. But when we look at the attribute information, again, I want to just point this out, what we see here is that all of the information from the original and from the other is maintained. So we have all the information from Butler, all of it from Mercer, and you're going to notice, I want to point out kind of something here, that in this case, because I'd already clipped my data, what we will see here is that the results that we have here from my union are not significantly different from what I would get from my identity. This happens to be because I've clipped these 2 data sets prior, and that kind of constrains what we see here. But again, union is everything. Intersection is only the co-occurrent. Now the last one that I do want to note, and it is in fact quite a useful tool, is the idea of the update. Now what update actually does, as kind of our last option, is the update tool allows us to put data in that has different geometries. The input geometry in this case is going to be our Butler County. And let's go back up, and I want to activate this so that you understand what we're going to be getting out of here. If you look at these 2 types of data, and if we, again, I want to imagine right here, we have Butler and Mercer County are 2 polygons. It's split right along that kind of northeast southwest edge. The drive time is a single polygon, and if I put it over it, what you'll notice is it essentially takes out that break in the data. In other words, it covers the divide between the two counties. Now, there are some scenarios where you want to maintain the geometry of one of the inputs and not that of the other. And so in this case, imagine putting these two together, but that the drive time maintains its internal geometry. And so what happens then in the update is we get a new single feature class. And again, I'm going to open this up in the update. Our input feature in this case is going to be the Butler-Mercer County. And then we're going to put our update is going to be the drive time. Now, what happens as a result of this is that when we push these two together, our resulting output is a single feature class. I'm going to activate this now so that we can see this. We have a single feature class that has maintained Mercer in the north, Butler in the south, but you'll notice that now the drive time is a single feature. And what's very important about this, when I click on this one, you're going to notice that when I look at its county FIPS, it's 85. When I look at Butler's county FIPS, again, it's maintained as 19. When I click here, the problem is because we have updated this, neither of those, you'll notice that the county FIPS is not present because, in fact, there is no single county FIPS for it. So when we update, again, we're going to add geometries, but where there are multiple attributes in a single field from one of the original inputs, that will be eliminated. So again, different ways of seeing the overlay of vector data. Okay, in the last of our tool sets, we will be looking at issues of proximity, and really we're only going to be looking at types of buffering. We'll do that in the next video.